Yes, we will talk about Unix basics first today, but before that, let's do a little bit recap. Okay? All right. So, okay. So first we talked about big data, then we talked about all the components of Hadoop, and then we talked about we talked about HDFS. In HDFS, we basically concluded that we require Hadoop distributed file system in order to store humongous data. And then afterwards, today and tomorrow, we will discuss how do you process such kind of data. Such kind of data which is in terabytes and is stored on a distributed file system such as HDFS. We are storing data in a manner which can be, so we are storing, we are using HDFS. We built a storage which can store petabytes of data without having to worry about anything. You just have to keep on adding devices and hardware, and you will keep on increasing the storage ability. Okay, so that was HDFS introduction we did on the previous session. Today, as discussed on the last session, I will do a quick recap of Linux, and I'll strongly recommend that all of you should try the console along with me. Okay, so all of you should try the console along with me, and that's a very important aspect of using the cloud labs. Okay, so first of all, everybody must have logged in into. Okay, all right, so you will see your login and the password here. Okay, so first of all, you open the console. All right, and then we copy the login, paste the login. Okay, then copy the password and paste the password. When you type or paste the password here, you won't see any asterisk character or any other character. Okay, so when we talk about Unix, the most important part is a console. There are two ways to log into this console. Right now, this console we are running in the browser. Same thing I could also do from the command prompt. Okay, so this is my command prompt. Let me close everything and then start again. So we have a terminal on. We have a terminal on. What do you say? We have a terminal on Mac. Okay. If you are on Mac, you can press command spacebar and type for search for terminal, and you will find it. Okay. Now on Windows, if you are on Windows and you want to log in from the Windows and you don't like the browser interface. Okay, ideally you would not require anything else. Okay, so to open the console of this machine, you will either need this web console, or you can directly use a command called SSH, or a, a application which you can install on Windows called Putty. Okay, so you could say SSH, and then my login ID. My login ID is Sandeep at h5.cloudxlab.com. Okay, I have to remove HTTP and all of this. Okay, so I'm trying to show you that you can either log in using command line, or you can directly log in using the browser. I prefer the browser one. Okay, Now you can see I've logged in here as well. Okay, so I'm logged in via console and I'm logged in via SSH. Okay, so either using the browser or using the console using SSH, or in case of Windows you could use putty and then log in into it. It is very important to understand um, that unlike Windows, so first of all, here we are going to talk about Linux, Unix, and all. They share the same basic principles and same terminology of everything. Okay, so we are going to work on Unix. Okay, so you could use a uname minus a command to find out which machine is this. Okay, anyway, let's not jump ahead. So first of all, we open the terminal, which means, what does it mean by this terminal? Here, if you run any command, you are running the command on this machine, which is located in New York. Okay, so basically, I am kind of transported to New York, whereby I'm typing any command and my command is being executed on that machine. Okay, so uh, this is very important because here, instead of bringing data to me, I am being transported there. Okay, so this is the command prompt from which the whole process starts. All right, but before the command prompt, I would like to emphasize on few things. All right, first is that in Unix, everything is a file. Okay, just like in Windows. And also, why do we need command prompt? First of all, why do we need command prompt? Okay, command prompt. This command prompt is also called shell. This is also called shell. SHELL. Okay. Uh, okay. So this is also called shell and also called command prompt in the Windows. And why do we need to work on this when there are so many graphical interfaces available? Why do we need to work on this? Let's understand this. Okay, so first, when we churn any data, we have to use many utilities, many automated systems. In those cases, command prompt is very powerful. As you will see when we do Hadoop streaming, that the command prompt is actually very powerful. Okay, you will notice that almost everything we could get through command prompt. So there are two ways to do. One is you are given a user interface and you are clicking with the mouse and getting the things done. Okay, this sounds, that one is very easy to learn, very easy to operate, but very difficult to automate. Telling the program that click on a window at this particular location is a very difficult thing. Okay, therefore using the commands is a very quick way to automate a lot of things. Okay, so that's the first thing to understand. Second is that this command prompt, anything you do here, you are executing that on h5.cloudxlab.com, and everybody is in their own account, so you are not going to disrupt other people's work. Okay, now let's jump in. So we are clear, right? That why do we need command prompt? Because it's easy to automate using command prompt. Okay, and you don't require high bandwidth to operate on command prompt. All right, so is everybody able to log in onto the console? Anand, Ashmit, Ashok, Ashwin, Dirpu, Inyan, Leela, Maimuna, Muhammad, Mohsin, Parvez, Prashant, Prabhu, Rajiv, Sneha, Sukhvinder, Saini, Satyan, Sundar, Vijay, Vishnu, Vivek. Brilliant. So everybody is able to log in. I'm pretty happy with this because this is the first thing which everybody fails to do in case of virtual machine. All right. Okay. So Muhammad and Sneha, yes, you have a question for me? Asharfi and Sneha, you've raised your hand. All right. All right. Command prompt means web console. Yes. The same console either you can open in the browser like this, or traditionally everybody logs in from SSH. This web console is something we figured out that we can provide our users a, a console from the browser itself. Okay, so that people don't have to install putty and other softwares, because on Windows the SSH command which connects to the remote is not available by default. On every Unix system, SSH command is by default installed. Okay. Sneha's question is, what you told about putty I did not get. So whenever you connect to the command prompt of a remote server, let's say tomorrow you join, say, a company like Amazon. So every time you have to work on a remote system, you will have to type a command from your machine using a program called SSH. Now on Mac machine, Linux machine, and other Linux desktop, this command called SSH is available, but on Windows it's not by default installed. So you might have to download putty from here, and then you can start working on that. All right. So it'll give you this kind of interface. Okay. It will show you this kind of interface. You see that? It'll show you this kind of interface. You can see this kind of interface, and if, basically after you download this putty and run it, you will have to type h5.cloudxlab.com and then say open, and it will open. So this is optional. Okay, this is optional, so that you know that in case you go in an organization and there is no such thing called web console, do not panic when you go to the practical experience. Okay, use putty on Windows and SSH on Mac. All right. Anand's question is, are there any co-hosts like last time to record backup session video? Anand, this time I do not have one. Should I make you one? That'll be great if somebody becomes. It's just that it becomes a distraction for me because they start typing in the chat window and others are typing in the questions window. All right. All right. So Sneha says she has used putty in the networking lab. All right. Yeah, on Ubuntu, you will already have SSH client installed called SSH, while on Windows, you will have to install putty because, okay. But in our case, we have provided a browser-based system so that you don't have to install anything. Okay, great, great. All right. All right, it's okay. I think. Let me just check if there's somebody else available. All right, I think there are some other people who are trying to connect. All right, it becomes a bit distraction for me. All right, but I'll just make say Satyam or okay. Let me make Anand. All right, Anand, I'm making you the co-organizer. Okay, so all right. Okay, so we start continuing. All right, so everybody's logged in into this console. This console is called SSH. You are connecting via a protocol called SSH, and this is the place where you type your commands. Okay, this is the place. Instead of unlike your Windows, what do you do in Windows? You go to a folder, double click on exe. That's how you execute programs in Windows, right? You go to or you click on one of the shortcuts and double click on the one of the shortcuts and it opens that program. Here, here you run the commands from the console. Again, we will talk about commands in a while, but let's talk about file system. Okay, let's talk about file system. What exactly is a file system? Okay, so this is something very important. This is something very important. So in case of Ubuntu or Linux, everything is a file. Everything is a file. Mouse connected to the machine is a file. If you are trying to talk to mouse, you can read that file and you are reading the data from the file. Okay? Even so in this Unix system, everything is a file. All right? So the root directory. And what is a file system? File system is a kind of way of organizing your data in which there are folders. So there is a default top level folder. The name of that folder is slash. Okay, the name of that folder is slash. Everybody is the children of that folder. Inside a folder, you can create more and more folders, and inside the folders you can create files, or you can write your programs, you can upload your data, and so on. Okay, and in case you want to upload some data to here, so this is our Linux system. When you say pwd, you know your current working directory. Right now, I am in my home directory called slash home slash Sandeepgiri 9034. Okay, and I say ls means show me the listing of all the files in this folder. Okay, ls shows all the files in this folder. All right, and rm deletes a file. Say for example, I'm trying to delete this particular file. Okay, so I could just say rm space pig and all right, so it has deleted that particular file. Let's say I want to delete all the files starting with pig underscore and ending with log. So I could say pig underscore asterisk dot log, which means I'm using a wildcard asterisk. It's not regular expression, but I'm just using a wildcard called asterisk. Okay, so now all the files starting with pig underscore and ending with dot log have been deleted. Okay, now under this, this is my home directory. Okay, you can see I am inside two label, home and then Sandeep Giri. You see that? Home underscore and then Sandeep Giri. If I say, okay, first of all, to change your directory, you could say cd. Okay, so let's say, and to see whether to see the details of the file, instead of saying ls, you could say ls minus l. All right, one step further and one step back. So we try to show you how to interact with the file system. Okay, so the only command we have used is ls and rm so far. Okay, so if you want to create your own directory, you could create, say, make directory 6fab. It says file already exists. Okay, so what should we do? We call it 6fab hdp. Okay, 6fab hpd. And so here you will see, if you say ls minus l, you want to see the details of the directory. You will see the details in this manner, where the first column is the permissions on this file. Okay, permissions we will discuss later. Then the owner of the file and the group of this file or folder. Okay, so 6fab is a file, while 6fab hpd is a directory. You can see d here, it means it's a directory. Okay, so we have just created a directory called 6fab hpd. Okay, inside this we can keep storing the data. Okay, all right, so basically whatever we are doing here, it's writing the data on the disk. Okay, so that even if the system reboots, this is going to be available again if the data is not corrupted. Also, whatever we are doing right now, we are doing on the machine, a local machine, a machine called h1 h5. It's not on HDFS. It is on H5. h5.cloudxlab.com is a computer just like mine and yours. Okay, and on this we are logged in from remote and working on this. All right, it has no special hardware. It has actually very reasonable hardware. Okay, so we are connected to this and we are working on this machine. Now let's say we want to change directory back. So we first, what we did cd and this folder called 6fab hpd, right? If you want to go up, we say cd and then say dot dot. Dot dot means above directory. Okay, and cd dot means current directory, which means it has no effect at all on cd. Cd means change directory. Cd directory name. If the directory name is dot dot, it means you're talking about the parent, so it goes up. All right, if you want to see my present working directory, it is this. If I go one more level up and the pwd, I am in the home directory. Earlier I was here. Before that I was inside 6fab, which is inside this, and then I've gone one level up. Now if I go one more level up, I will hit the root. Okay, you see my present working directory pwd, its present working directory. It shows that my current present working directory is slash. If I keep on doing this, it has no impact at all because I have reached the top level. Okay, I'm not going anywhere above this. All right, so I can't go above the present working directory. Perfect. Now here we are typing these commands. And what are these commands? Again, all of these commands are basically a file. You don't believe me? To find out where is this location, we say which ls. It says that ls is an alias and it is pointing to bin slash ls. Okay, now we can say ls minus l and provide the name of this file called bin slash ls, and you can see that it's a file. Okay, you can see it's a file with the following permissions. Okay, if you delete this file, nobody will be able to do ls on this machine. All right, so now we said ls so far. We could also say slash bin slash ls. Correct? This is the absolute location while calling a program. Or we could say dot dot slash dot dot and then bin and ls. All these three things mean the same thing. How? When we say ls, this command prompt will look into a variable. There is something called environment variable. Okay, it will look into the directory called bin slash bin directory that's defined as part of that variable. And so when you say ls, it's going to find out in the path where is this file located and will locate it by itself. Now, so either we could say ls or we could say slash bin slash ls in case we know exactly where our ls command exists. So, and this ls is nothing but a program. Like me and you can also create such program, and we will create such programs which we can be executed. Second, this bin slash ls is absolute path location of ls. All right, the most important part is that the file which you're trying to execute should have x here. It should have x. Okay, it should be in the executable mode. So Parvez's question is, what is my login? I'm connected 10 minutes late. You can log in into no big data. Do you see the cloudx lab details? That is your login, Parvez. Let me know if you are not able to see it. All right, so this is where we are. Now the second format is very important. Whenever you refer to a file, you can also refer like parent slash means inside parent go to this folder. Okay, so we say the way we have said, go to the root, then go to a directory called bin, and then go to ls. Okay, now everywhere this is how. Yes, Ashok. X means here, whenever you see X, and X means executable. Okay, we will go in deep into the permissions, but just know that whenever you are creating your program, okay, you always refer to it as ls. Okay, let's say I have created called my hello. Okay, you see my hello.py. Okay, that's a little too big for us. Do I have a simple program? All right. So you have this program called te.py. I had written this program in Python. You don't need to learn Python for this. All it does is it reads a number. Okay. It reads a number call and then execute it. Okay. So if you want to execute this Python program, we could say Python te.py. Okay, and it'll so it executed. And or you could say python and then we could say dot slash te.py. Okay, dot means current working directory. All right, so coming back to it. All right, so the way we executed ls command was either type ls, type bin slash ls, type dot dot slash dot dot, um, dot dot slash dot dot slash dot dot slash bin slash ls. Okay, because extra dot dot does not have effect if you have already hit the root. Or you could go up again, you could go up. Now you see here it shows that you are at slash. Under that you could go bin. Now our present working directory is slash bin. Here we could say dot slash ls. Sounds good? So this is the way you refer to any file. Sukhvinder is saying, how can we view the programming behind ls? Unfortunately, if you check, there is a command called file. Okay? This file command tells you that what is inside the program or inside any data file. So if I give it file t.py, okay, let me just go to my home folder. A shortcut to go to the home folder is cd tilde or only cd. Okay, either way you go to the home folder. All right, now this is my home folder. Every user is given their separate home folder so that they don't spoil each other's data. Okay, your home folder is only writable by you. My home folder is readable by everybody, so that in case you want to see my files, you can go to this folder and check out. Okay, this is my folder name. I'm copy pasting it. If you want to check out, you can do a cd into my folder, and then you can say cd this, and you'll be in my folder. And then you can see ls, because I have given the permission to everybody to execute. You can basically execute commands in my home folder. All right, let me just change the. All right, so right now in we are in our home folder. Okay, so that was a very simple way and not simple way, quick way to introduce Unix. So we always refer to a file using either the absolute path or the relative path. All right, so this is our command prompt. This is where we will be interacting with Hadoop. Okay, I prefer the command line way, though we have other viewers such as you, which provide you a UI with which you don't have to type the commands. Okay, but I prefer this way sometimes because it gives us little more control. All right, so till now we have only talked about local file system. Okay, so along with this, you're also given Hadoop file system. And as we talked earlier, Hadoop file system is singular. Okay, file a file system which has many multiple machines to store data on, but there is a single name node. Okay, so right now we have h1.cloudxlab.com, which is the name node, and right now we are logged in onto h5.cloudxlab.com, which is one of the data nodes as well. Okay, so far today, whatever we have discussed about ls and every command, we only talked about local file system. Now, in case you want to interact with HDFS, the way you do is you say Hadoop and fs. It will show you all possible commands you can execute on the HDFS. So you could say HDFS minus ls. What does ls do? You can see that it has these parameters. Okay. Also, you can say minus help and ls. It shows you that minus ls command. So the way to interact with HDFS is a Unix command called Hadoop fs. This needs to be installed. Okay, but we have already installed on the cloud, so we have all of this available for all of you. Okay, so we have Hadoop fs minus help, and if you do not type any help or anything, it'll give you the list of all the files, all the options on this. Okay, so getting back to it. So the way you execute, anyway, let me just close all of this so that we are no longer confused. Good. Now going back to my web terminal. All right. So we talked about how to execute commands, and on every command like ls, we can provide arguments. These are arguments which are given to your program. You remember, if you had worked on C or Java or anything, every program is supposed to have a main function, and in that main function you have arguments. These are those arguments. We are providing various kinds of switches or options or arguments on the command line after ls. Okay, so we can, if you want to convey more things to ls, we can provide those on the command prompt. Okay, if you want to see what are the options available on ls, we could say minus minus help. Okay, you can see that. You can, all the details about this is available. Also, you can say man ls or man any command for finding out more information about ls. So every command is a file which is in executable mode. You can call it by either putting that name in the environment variable called path, okay, or you can call it by the way of absolute path or relative path. Okay, so if you don't want to put something, if you don't want to put something into, if you don't want to call them, if you don't want to call a program by absolute name or relative name, you can call it, if you can put that folder in your path by saying export path equals to dollar path, and then you can put the name of the folder. Right now I'm saying dot. Okay, that means my current folder is a part of my path, which means anywhere I am, if I want to execute some program from here, let's say my cmd.sh, this is one program I have created, so it has been launched. If we do not provide that, we should tell dot slash my cmd.sh, which is the relative path from the current directory. Okay, so relative path and absolute path are very important, and most of the programs you can call by by using this. All right. Similarly, on the same lines, we always talk about Hadoop. We just showed you a command called Hadoop fs. Now this Hadoop is also a file. How do you find where is it located? Use a program called which basically tells where is this file located. Now we can check by using ls minus l and providing an argument that what is this file about. It shows us that it's a link. It's a link. Bin Hadoop is a link pointing to this big URL. Now, if I have to find out what is this URL, it shows that it's a file actually. Okay. Now, what is inside this file? Either we can start editing this file or use a very magical command called file. This command called file is very magical. It basically tries to understand what is there inside the program. Okay, it tries to understand from few bytes from the file and tries to decipher whether it's a binary program, it's a plain text, it's a SQL, or it's a Python, or it's C. Okay, so it has showed that it's a born shell script. Okay, now similarly, if I say my cmd.sh, now it'll tell it's a shell command. If I say it's and mind it, it's not trying to guess it based on the the what do you say, based on the suffix. Let's say I change widget.java's name to simply widgets. Okay, widgets, let's say J, I'm writing its name. Now even if now you can see it has, okay, and yes, all right, it is saying that it's ASCII text, it's not Java. Let me, okay, so actually it's not, it's thinking that this Java program is not a proper program. Okay, let's just see what is there inside it. Okay, it shows that it has very long line. So basically, like my hello.py, let's see what it says. It's again, it says that it's a Python script. You can see that it's a Python script. All right, so that's the magic thing about this file command. It can tell you exactly what is there inside a file. All right, these are the few tricks I could tell you. So we found out that what is our Hadoop command. We first use which. Okay, similarly, we can also find which Java are we using. It says, okay, your Java command is located here. We can see more details about this. It says that it's pointing to some other folder. Okay, then we go to that folder. Oh, this is again pointing to some other folder. All right, we say ls minus ls and and jre bin java. Okay, it says that this is a proper one. Now this one we can use file command, and it says that it's a 64-bit lsb executable. It's a binary file. All right, so that's a magic thing about file command. It tells you what is there on a machine. All right, so this way you can Ashok, I hope you got the answer, and Sukhvinder also. So question from Parvez is, how to copy paste command string while working on command prompt. Try right clicking or control plus shift plus C or V. Okay, try these command. I'm not sure. All right, so this was a quick overview on the Linux command. All right, if you want to see what processes are running, so whenever you execute a command, it starts a program. This program, this program might be a long running process, or it might be a short running process. Okay, this program might be a long running process or might be a very short running process. Okay, but every program starts whenever you execute a command. Here on the prompt, it starts a program. What is a program? A file loaded into the memory and instructions being executed as mentioned in the file. Okay, so we tell the computer that, hey, my program is located in this file called ls. Okay, and please execute this ls. And this ls will do the job of finding all the folders in the current working directory and give you the list. Sounds interesting? All right. So that was My Mona is saying that Control C and Control V is working for me. So, are you using Windows? Parvez, everybody is muted. You want me to unmute you? All right. Let me unmute you for a second. Okay. But then it'll be only for temporary. Okay. And then I'll have to mute you again. All right. Yes, go ahead, Parvez.
Hello, Sandeep sir.
Yeah.
Hi.
Hi.
Yeah, sir, while you were answering my question, my
Mhm.
audio was gone for a while, so I could not get it anything for
Okay.
copying and pasting the command.
Okay. Okay. Okay.
Okay.
Okay.
Please
So,
repeat it.
yeah.
Thank you.
Okay. All right. I thought. All right. Never mind. Okay. So, I thought he was not able to communicate. So, yeah. So, in my. Okay. So in Maimona's case, he's able to copy paste by using Control C and Control V. Okay. If you are on Mac, you can use Command C and Command V. Okay, to copy anything. All right, you can try it. But if you are on Command prompt without selecting anything, if you press Control C, it will it will basically end that some process in the background. Good. Good. Now, moving ahead. So we talked about what is a process and how does it work. So when you start a process by executing a command, you can see that it will come in the PS or it'll come in it'll come in something called PS tree. Okay? PS tree shows the whole structure of processes. This is not directory. These are processes. A process is again a kind of, say for example, I'm logged in right now. If I start a command, it is going to start a process which will be the child command of this command prompt. Okay, you can see, I'll show you ps minus u, and I'm saying that explicitly only show me the ps tree of only this user. It says that the parent process is bash and child process is ps tree. Why? Because ps tree itself is a command. Okay, so it shows that the bash is my shell. This place where I'm standing right now is running a process. Okay, this process is listening to my commands and I'm typing those commands. And therefore it says that bash is bourne shell, and this is basically a program which listens to my commands and executes those commands on the Unix. All right. So when you connect over SSH, you are basically given, you are uh, on your behalf, it executes a program called bash, which listens to your commands and executes them. And when I executed PS3, PS3 was basically a child process of a process called bash. And both these processes, bash and PS3, are owned by me. They are they represent my user ID. Anything they do, if they create a file, if they delete a file, anything they do, they are doing on my behalf. They cannot suddenly become root or somebody else so easily. Okay, though they can become sometimes. Okay, Satyan cannot hear me. Is everybody else able to hear me? I hope my network connectivity is perfect. All right, so everybody is able to hear me clearly. All right. Okay. All right. So everybody, so we talked about processes. Now processes again um, execute in the memory of the computer. When you run a program, when you type a command, what is actually happening? It reads the instructions from that command and loads it into the memory and then does the other work. All right. That's how the program happens. Um, I know that it's not a computer science class, but yeah, I want to connect everything end to end. That's fine. All right. So now we talked briefly about Hadoop command. Hadoop is also another command. Okay. Hadoop provides you many argument. You can see fs version jar. Let's check what is the version of Hadoop we are using. All right. It shows that we are using Hadoop 2.7. Okay. And this particular and the other details. Okay. Good. Now, next is that's our Hadoop version command. Then Hadoop fs command provides us with interaction with HDFS. All right. So the first and foremost command is -ls. -ls shows the listing of my data in my HDFS folder. HDFS also provides everybody a home directory. This is your home directory, just like our local home directory. So everybody clear about what is the difference between Hadoop fs minus ls and ls? Okay, so there are good questions. I'll answer Prabhu's question. Okay, all right. So when we are on data nodes, okay, when we are on any other nodes, right now, whenever we say ls, we are only going to talk to name node, right? We are only going to talk to name node. So when we say Hadoop fs minus ls, it basically finds out who is our name node. And how does it find out? From the configuration folder. So every machine has a configuration folder called etc Hadoop. In this, you have conf, and in this, you have HDFS site. In this, it is clearly mentioned who is name node. Okay, it clearly mentions that who is our name node. Okay, so it shows that the data node is located on local machine, and okay, and you can see that the other properties of the HDFS is defined here. Let me try to find out where is that location. Yes, all right. It would be somewhere here only. You can see that here we have defined the name of the name node. So this machine knows this Hadoop fs command will go to this particular file and find out the host name of the name node. Okay, so it will find out the host name of name node and talk to the name node and find out the list of files in my home directory. Okay, you can see that. And my home directory is slash user slash Sandeep 9034. We have created a user name in HDFS with your same ID, same login which we have provided to you. Okay. All right. So now again in the HDFS itself, the folder structure is there. So you can see that when I say Hadoop fs minus ls, I can optionally provide a folder name, meaning show me the list of files in HDFS in this folder. Right now you can see these are the folders. All right. Now you can see clearly the difference between ls minus ls and slash. This one is only showing me the local Unix machine folder. Okay, had there been no Hadoop, still second command will work, this command will not work. Okay, because ls minus l is as if you are going to this folder, this machine's local folder, and then giving the list. And you can see the visible difference. Here there are only 7, 8 folders, 9 folders, and here there are 128 folders. Okay, you can see that. Are these 128? Something wrong with that. All right. Okay. So in this case, I'm talking to Hadoop this command, Hadoop command is our gateway. This is that client driver. You remember? We talked about client driver again and again. This is that command which contains the driver. All right. And this is our gateway to talking to HDFS. So Hadoop fs minus ls essentially talks to the name node and gives us the list. All right. Prabhunath, is it clear to you? Yeah. Yes, Prabhunath. All right. Good. This is very, very important because you guys should become totally comfortable with it so that there is no confusion of local file directory and the remote one. Okay. A lot of time what would happen is you will create a folder here and then you will say Hadoop fs minus ls and you will find, okay, my folder is not available. All right, let me try to answer your question. Then we'll talk about how to copy the files. Is your root directory list fs minus l on Hadoop gives the Hadoop file details? Okay, is your root directory list and fs minus ls l? Yes, yes, you got it right. All right. Sneha's question is, what is the difference between Hadoop ls and Hadoop ls minus l? Same difference in case of Hadoop fs minus ls minus l. It gives us, okay, by default, it is actually ls minus l. Okay. There is no such thing called ls minus l in case of Hadoop. You can see that if you try to give this, it says that illegal option minus L, please either provide minus D, minus H, minus R. Okay. The interesting part is if you provide minus R, it's going to recursively go into every folder. It is going to recursively go into every folder. You can see that and list the name of the files. All right. So I hope that's clear. Prabhunath is saying that looks like we don't have access to etc directory. No, everybody has access to etc directory. You can see that ls slash etc. You can see here the what do you say, the folder name, the folder called ls, this one ls minus l. It has got the read permission for all r r r. Okay. Now, so everybody has that. A question from Ravi is, while you are here, could we cover user and user groups? I know it's not related to Unix, but okay, yes, we will cover that. All right. I think, okay. So main question from Rajiv is that if we have 5 data nodes, then do we need to define same user and group at all 5 data nodes? Okay. Yes, you do. All right. All right. Leela's question is how to make directory in Hadoop. I'll show you that. Okay, that is something I was coming to, and then I'll talk to Prabhunath, and we'll have. So you should generally check Hadoop fs command, and there you will see all the available commands. Okay. First one is append to a file. If you have a local file and you want to just append to existing file in HDFS, you can use this. Cat shows the file from the HDFS. So first of all, let me answer other questions, and then you basically use mkdir. All right. We will talk about it in a minute. Okay. Prabhunath's question is, it's a very interesting question. Okay, it's a very interesting question. Everybody should pay attention to it. Question is, do we usually connect to data node and run commands? Okay, do we usually connect to data node and run commands? Not really. Any machine which is having the Hadoop client can talk to Hadoop cluster, can talk to name node. It does not need to be made as data node. Okay, so any machine which is having this command called Hadoop, so all you need to do is install this command called Hadoop and edit the HDFS XML. Although, and this Ambari provides you a way of installing only the client, only the client without having to install the data node. Okay, so Hadoop command is all you need. And this is your driver. It talks to the name node and then does the job. All right. Sukhvinder's question is, what does this mean? Okay, so there are two questions, two hot questions which I need to answer. Okay, let me try to answer that. Okay, a quick question from Satyan. Let me answer that. Is Hadoop client similar to Unix Cell? Kind of, but uh, it is a subset. Okay, and there are few more commands. Okay, it basically Hadoop client provides you with all these kind of options. Okay, you could see that Hadoop FS. You could see there are these many commands only. All right. All right, then we will interact aggressively with Hadoop HDFS and try to do other things like setting up home directory and everything. Okay, now let me first describe these processes. Okay, these permissions. I think it's very important to describe the permission. It's very important to describe the permission. Let me just, all right. Let me first describe the permission on the local folder. When I say ls minus l, it shows us who created the file, who created the file, Okay, and who are these users? All right, now this section is the permission of the file. Okay, this section is the permission of the file, and this is the username. This is the username. I mean, the user who created the file, the owner. We call it owner. Okay, we call it owner, and this guy is called as group. Okay, this is the name of the file. This is the name of the file. This is the size. This is size. Okay, this is our the size, and this is the name of the group. Sounds interesting. All right, and this is the time at which the file was modified. So every file has these. Right now I'm talking about classic Unix file system, and as a matter of fact, all the file system, whether Windows or everybody, has a similar kind of model where you have a file name, and then you have owner, and then you have group, and you have others. All right. Parvez is saying that he's not able to log in with my username and password. All right, that's a little tricky situation to be in. Um, can I give you my account till then? Just that I'm very afraid that you might delete things by mistake, and you may be afraid of doing things because of that. All right. Okay. Um, how should I do? All right. I think I have a solution to your problem. What is your email ID, Parvez? All right. It won't be possible for me. Okay. Can you just click on show password and then use that? Okay. All right. Yes. Rajiv, could you share your account? Okay. Actually, I want to create your separate account. That's the reason. Because I want everybody to be free while trying things rather than be afraid that they might spoil somebody else's data. That is one of the reasons we have created everybody's account separately. Although I've shared all my data via, I mean, made it accessible to everyone. Okay, Parvez, just give it one more try by clicking on show password and then typing it, and then let me know if you are able to do that. All right, never mind. So I'm not able to do this. Okay, okay. So I was explaining to you the permissions, right? So this is the permission which is very important. This is permissions. And there are these attributes associated with file. Every file says that my owner is my owner is my owner is this guy, my group is this guy, and my permissions are these. These are the attributes. Now, what does these permissions mean? These permissions, as you see them here, okay, let me try to paste it. All right, let me try to paste it and zoom in. How do I zoom in? How do you generally? Okay, all right, never mind. So I'll just try to separate it out. So these permissions are basically made up of three parts. Okay, okay. So dash means not allowed. Okay, while okay, here what does it say? It has three parts. First, okay, this part in the beginning. I'm sorry. How can I? Okay, never mind. So we'll just do this. All right. So I'll describe to you a few more things. So in a permission, I think this is something which will be useful for even those who have been working. So the first one is the kind of okay. So here it is a kind of either directory or file or link, etc. So the first first character means this. Okay. Dash means it is a file. Okay. Dash means it's a file. If it's a directory, it says D. If it's a link, it says L. So the first one is the representative of what kind of file are we talking to. Okay. What kind of file are we talking to? Second part of the permission is owner, group, and others. Okay. Owner, owner, this guy is the owner, this guy is the group, and this guy the other. So what does it mean? It means that group and others. Okay, it means that owner can do these things, RWX, group can only do R and X, others can do R and X. What does it mean? Means owner can read the file. Who is owner? Sandeep Giri 9034. All the people whose there will be only one user ID. The user ID Sandeep Giri is allowed to read, write, and execute this file. That's what it means. It means RWX. It means the owner of this file called Sandeep Giri 9034 is allowed to read, write, and execute. What does it mean by writing? It means he's allowed to delete this file, edit this file, and and read this file. Okay, as well as he's allowed to run this program. Had it been, it, it's an executable file. Okay, it's an executable file, therefore user can execute it. Although although while running it might say we could not find a way to execute this program, this doesn't look like a program. That's another issue, but permissioning is allowing the user to execute the file. Okay, now group, meaning the people who are part of this group. people who are part of this group can execute, read, and the file. But the group members are not allowed to modify this file. Okay? Similarly, other people who are neither having this user ID nor are the members of this group. Okay? They are they are only allowed to read and write this file. Make sense to you? If let's say I decided that I create a folder for this 6th February batch, all I will do is I will create a Unix group for all of you and then add all of you into that group. Next thing I will do is create a directory on which I change the group of this file to that group which I've created so that all of you will be able to access the file but others won't be. Okay, so that is the magic. That's the magic of these permissions. Okay, now how do you change the owner, change the group, and change the permissions? You use the commands for changing the owner. You use change owner. To change the group, you use ch group command, and to change the permissions, you use ch mode. Okay, so these are the basics of. You should go through ch own, ch group, and ch mode. That'll be simple for you. Okay, so these are the basics of Unix permissioning. And interestingly, same permissions are also same definition of permissioning is also applicable to HDFS. Just that you will have to create the user in HDFS with the same name, same login as the current user, current local user. Okay? Make sense to you, everyone? All right. So if I write now, let's say there is this directory I'm standing in. And what I do is I allow you, okay, I say 6fab, for example. What was 6fab having? It is having just some data. This is my data. I check the file, what is there inside this data? It says it's everybody can read it. Are you able to read it from my folder? Are you able to say cd slash home slash this folder? Are you able to do? And if you want to see what is there inside a file, you can use a command called nano and you can edit the file. Okay? Using nano command, you can open the editor. Although there are many editors including VI, but nano seems to be the most user friendly. Therefore, I'm talking about nano. Okay? Yes. So group members and others have the same permissions, Sneha. Now let's say I decide to change it. I decide that others can also modify this file. Others can also modify this file. Okay. So what I do is ch mode and I say O means others plus W meaning others can edit this file called 6fab. Now one of you can try to edit this file called 6fab. Okay. So Sneha's question is, what is the difference when others and groups have the same permissions? Right now there is none. But sometimes you may want to have different permissions. Let's say I want to change the group of this file to all the peoples who are part of Hadoop groups. okay, or KBD groups. Okay, I say that only the people from KBD group can edit this file. So what I do is change group to KBD for the file called 6fab. Okay, now you see that. You see what is the group of 6fab? It's KBD. And I could say that ch mode others can't write while group can write. Okay, group can write. Okay, now you can see that uh, other than the people who are part of KBD, meaning users who are not the member of KBD group, because our system is being utilized by other people as well. So only our students will be allowed to access this file or change this file at this moment, while others will be able to only read this file. Make sense to you now? So you can are you using nano command to see what is there inside the file? You can also do cat 6fab and see Sukhvinder was able to edit this file. Yes, that's right, Anand. Anand is saying what is the command to create new group and add user ID to the group. So there is something called user group add. Okay, since I'm not the super user, I'm not allowed to execute that command. Okay, same philosophy, whatever we have learned so far, you have learned so far. uh, okay, we have not. So that same applies here also. There, basically the permission on group add command itself, we are not allowed because if everybody starts creating groups, it will be a chaos. Only the super users are allowed to do so. Okay, all right. So this is great. I hope everybody's question getting answered. I know it takes a bit of time to get used to these permissions, but trust me, it is going to be total worth of your time because every data engineering is going to be command line based. Most of the data engineering requires you to go and have the understanding of Unix command. As a matter of fact, as a matter of fact, even the systems of Windows were at a time, for example, for Bing, in case of high performance, they had to adopt certain part of Linux for their high performancing. So all I'm saying is, whenever there would be data engineering, you would be expected to know the console, the Linux, and the commands, and the philosophy of permissions and the file system. All right, this is something imperative, and it would add a lot of value. It will add a lot of value to your profile to learn and dig deeper or experiment a little bit more. You can't damage our system, so feel free to try things out. Okay? We have tried our best to keep it secure. Yeah. So by mistake, you won't be able to do much of a damage. Question from Sukhvinder is, if you are not the owner of the file, but would you be able to run chown or chgroup given 77 on that permission? All right, brilliant question. No, only the owner is allowed to change the permissions of a file. Only the owner is allowed to change the permission of the file. Okay. My Manoj's question is, what do I do once I'm in Nano? Basically, Nano is a kind of text-based editor. Okay. Here you can type anything and then press Control X and save. And now I have a file called E, which I can check what is inside E using a command called cat. Cat basically prints whatever is the content inside a file onto the screen. Okay, I can delete E using rm command. Onion is saying that I'm not able to see the Hadoop folder called this. That's right. Why? Good point. Good point. So there is no such folder called this in Hadoop. Why? Because this is a local directory we are talking about. Okay, this is the local home directory we are talking about. All right. So I think, okay. Yeah, if you are not the owner of the file, okay, you won't be able to change ch own or ch group the file. Okay, even if you have 777 on the files. Okay, so which part did I miss, Sukhvinder? All right, good. Okay, okay. So what he's saying, let me just see. Okay, what does T means? Read, write, execute, and T. All right. I think T is something I'm not sure what does it mean. So you can just go through the permissions. Okay. So I'll have to figure it out. Maybe something they have included in the permission that I need to figure out. All right. Okay. Not sure. This is something we will do later. All right. How to come out from Nano? You can basically press Control X and then you can save. All right. So, okay. So there is some sticky bit called T. Okay. The as per Dirpu. And here is some more light to it. Okay. Good. Thank you, Dirpu. All right. This is interesting. This I did not know. A sticky bit is a permission bit that is set on a directory that allows only the owner of the file within the directory or the root user to delete or rename the file. No other user has the privilege to delete the file created by some other user. This is very good. So sometimes you want is that people can modify but cannot delete. In these cases, you can mark it as T. You can say G plus T, chmod G plus T, and thereby it'll become that. All right. So this was a brief introduction of this. Now we will get into Hadoop and we will talk about cat cat copy, as in upload and others. Okay, and also we will change the replication factor and check the status. Okay, we'll do all of this with the HDFS after the break. Okay, so we are going to take break for 10 minutes and back by 10 oh 10 15 p.m. IST. Okay. Right? All right, I'm back. Should we start now? Okay, so all right, this is a good cheat sheet you can try. Okay, you can try this cheat sheet and try to learn. If you want more details about any of these commands, you can simply come to the console and say man and that command. Okay, you can press Q here to exit. Okay, so you can learn more about each of these commands using from this file. This is thank you. This is a good cheat sheet, and I think I should also cover it. I'm sending it to all. This looks good. All right. All right. We will talk about piping commands. Okay. Or should we leave it till a little while later? Piping. Okay. We'll talk about piping, and we will also talk about other commands. All right. There are a few questions I need to answer. All right. A question from Prabhunath. I tried to access mm, second unique session this quiz. Yes, it is same. Yes, actually, most of the questions in first one also include the map reduce and process tracker part, so it would be same. Okay, Leela's question is how can we see your Hadoop file system file? Okay, I'll come back to this. All right, so a little more on the Unix command line side. Okay, so right now we talked about how to execute a command, how to provide various arguments to it. What if we have to pass the output of one command to another? Okay, what if we want to pass the output of one command to another? All right, so let's first understand that there is a command called WC. What does WC? WC does a very simple job. It basically does the word counting. We say this something and this, and when I end it, how do we end it? Press Control D. As soon as you press Control D, it prints number of lines, number of words, and number of characters. So WC takes the input from the user and then counts the number of lines and words and characters and prints onto the screen. All right. So Leela is saying that can you send the cheat sheet in email? Let me put it in the to do. Okay. All right. So now we talked about two things: ls, which lists the files, direct files, and wc. WC, anything you type in, it basically counts number of characters, number of words, and number of lines. All right. Now let's say you want to count number of characters, number of words, and number of letters in the ls output, meaning the data given to you by ls, you want to give it to wc. Okay, you want to give it to wc. All right, one way could be that you save this data inside a file. Okay, how do you save some data inside a file? By putting the arrow like this, and we can say my list. Now inside my list, all the output of ls has gone. You can see that all the output of ls has gone into this file. It's a file that contains the output of ls. Did you notice this? Now Okay, now we could say WC my list, and it has counted number of characters inside my list, number of words, and number of lines. Make sense to you? But this is too clumsy. For every program, we are passing, first creating the file, and then we are passing that file to another one, and so on. What if ls and wc we could stitch together? We could say ls and then pipe and wc. Now here is the magic that happens. The output of ls starts going into wc. The output of ls command starts going into wc. And you see the magic? It does the counting for you instantaneously. Furthermore, please note, furthermore, you can pipe the output like this. And you can keep on doing it again and again. All right. So basically, the output of ls went to wc. wc counted the number of characters, words in the output of ls. Similarly, the output of wc, which is this, went to another wc, and you can see it has counted 24 characters. From the beginning, it's counting the spaces as well, and therefore it's saying there are 24 characters, 3 words, and a single line. So that's pretty much about piping. So any program which takes the input from you, okay, any program which takes the input from you can take the input from another program. Similarly, let's say you're executing a command called grab Sandeep. It's going to find only the lines which contain the word called Sandeep. Now, if I say Sandeep Giri and I say Leela, in case of Leela, it did not print anything. Instead, while in case of Sandeep Giri, it printed something. All right. So you could pipe the output of ls, okay, to grep. Grep is a command which looks for a word in the input and then print only those lines which contain the particular word. Let's say I said grep x, it has only printed the lines, it has only printed the lines which contain the letter x. Okay? So that's the magic about the piping. The output of ls went into grep and grep did something. Now, we could do some more thing. We could say grep a, and you can see the a is contained in so many words. Now we can take a one step further, pipe the output of grep into sort. It sorted the data. You can see that it has sorted the data. All right. And you could further go ahead and say unique. Unique basically finds the unique words in it finds the unique words in the data which is ordered. If the data is not sorted, unique does not work. All right. So here right now all files are unique. Therefore, there is not much of a difference. Okay, so this is a quick case of sorting, piping. So we pipe the data output of ls to grep, where only those lines that contain a were printed out, and then we pipe the output of this pipeline, the current pipeline, to sort, which sorted the data, and then we passed it to unique. Okay, and we could also have done WC. So you could rearrange these pipelines and create really, really complex systems. And that is the wonderful thing about Unix. This is the powerful thing about Unix. And you will see further that we will exploit all of these commands to run MapReduce and to do MapReduce in a single shot rather than writing a lot of code. Okay, you will see all of this. How do we do word count in using Hadoop streaming using command cells? Is everybody with me? Okay. I hope I have not completely got disconnected from you. Okay. So Prasant is with me. Great, Maimona. All right. Brilliant. So looks like I was able to explain. No? All right. So this way we pipeline, and you will see the magic of pipelining as we go ahead, and we will exploit all of this to run MapReduce and see how we can utilize the available Unix utilities to do big data churning. Okay, this might sound little arcane because these commands have existed since 1980s. Okay, I mean before my birth. So, uh, so these commands might sound a little arcane, a little old, but they are still more valuable than most of data science tools. For cleaning the data, for reordering the data, for various kinds of data churning, we will use it aggressively. Okay, and most of us actually use these tools, these Unix tools very often. Okay, so Aswini's question is, which order does sort do? By default it does. By default it sorts the input into a lexical way, meaning the way things are stored in dictionary as in Oxford dictionary or whatever. So sort basically sorts in that manner. Okay, it's case sensitive. Capitals come before the small letters and so on. All right, based on the ASCII value of each character. All right, great. If you are with me at this point of time, okay, I'm really glad. Okay, because by this time most of us lose context, and I would like to explain in case you get stuck somewhere. Okay, if somebody is complete beginner with respect to Unix, try it out. If you get stuck completely, you can schedule a one-on-one with me. Okay, schedule a one-on-one with me, and then we I can take you through each and every step. I very well understand that everybody needs to start somewhere, and this could be that somewhere. Okay, so just drop me an email for request for one-on-one. We can do it over the week. Okay, you just suggest me 3 time slots. Okay, and then we can schedule a one-on-one for half an hour, and we can walk you through. All right. Basically, unique finds the unique words in a file. All right, unique lines in an input. All right, Ashok, yes, that's correct. That's the reason why capital A comes before the small a. Brilliant. All right, great. So moving on here, and all right. So I think everybody, I think I've covered most of it. All right. Let me now talk about HDFS a little bit more. Okay. So what we will do is we will first upload a file. First create a local file. Let me just create a local file. I'm creating a local file called 6fab hdfs file.txt. I'm using nano editor. I'm typing, say this is my data, and this is really secret. Okay, and I'm control X and Y and enter. Now this data is saved. Okay, now let's upload this file into my home folder in HDFS. Okay, let's first check what is there in my home folder in HDFS. I'm saying Hadoop FS minus ls. So this one talks to HDFS, which is the name node, and gets me the list. Okay, and keep in mind that when I say Hadoop FS minus ls, it's going to talk to the the name node. All right, now let's say I want to upload a file, the recently created file. We say copy from local. I'm copying the data from my local folder and uploading it, okay, uploading into my home folder in HDFS. Since I have not provided a destination in this, it will copy this local file into my home folder in HDFS. Okay, so right now we are interacting with HDFS using our from our H5. Okay, if we log in into H6 or H4, if we log in into H4, still the we will be able to talk to the HDFS in the same manner, because name node is same for all. Name node for H4, H1, H2, H3, H4, H5, for everyone name node is same. Therefore, if you want to upload a file, okay, into HDFS, it's going to be the same folder everywhere. All right, let me just show you that even if you log in from Hue is running on H4, and Hue is a web-based interface to talk to Hadoop. So Hue internally is making a call to Hadoop FS. Okay, and you can see that the file has been uploaded here. My home directory in case of HDFS is this, while in the local folder it was this. It was slash home slash this. Okay, now you could see, let me sort the data by date. You could see that this file has been created. All right, this file has been created. All right, now after uploading the file, I deleted my local file. I deleted somehow, I thought it's not needed. I deleted my local file. Yes, Anand. Anand's question is, what if I'm logging from H1, okay, which can be both name node and data node? Copy from local will be the same. Okay, it will be the same. All right, because it's the same name node running on the local host. And even if I'm standing on the same host and talking to the name node is a service which is running listening on a particular port, and I'm talking to it. So the behavior of it would be exactly same whether I'm on H1, H2, H3, or H4 or H5, or even on an external machine. Brilliant. Okay, so right now I've deleted my local file and I want to see what is there in the file on the web, on the HDFS. So I say Hadoop fs minus cat. All right. Now let us say I want to see what is the Replication factor. Now, quick question to all of you. This command, Hadoop fs minus cat, this, it talked to name node or only data node or both? Did it talk to name node, data node, or both? So I'm saying Hadoop fs minus cat and file name. So I'm trying to get the data, what is inside the file. So will it talk to name node, data node, or both? Anand, do you want to change your question? Change your answer? Yes, you are right. Yes, you are right. It will talk to both. So this Hadoop fs minus cat command, it's going to talk to name node first and say, hey, can you tell me where are the blocks of this file located? And then name node will tell you, you go to h1.cloudxlab as well as you could go to h2.cloudxlab and get the data. Okay, so this command is going to talk to both of them. And how many blocks are there? Anybody? For this file, how many blocks are there? Okay. So I'm without counting the replica, okay, how many blocks this file will have? Yes, it is going to have one block and three replica. Okay, three replication factor. And how do you find out about the replication factor? It's it's listed here. I will show you. I will show you that when we did this, okay, when we do ls, it shows the replication factor in case in here. You see 3 here? This is the replication factor. Do you see 3 here? This is the replication factor. Okay? Which means there are 3 machines having the block dedicated to this one. Okay? And how do you find the block containing this? So you could say HDFS, HD, HDFS admin. Okay? So you could use the HDFS command. Okay? HDFS admin command. Okay? So for each file, we could comfortably say, okay, you could say, see that I've used a command called hdfsfsck for every admin command. Okay, just a second. Files. Just a second. I'll just give you the exact syntax. Yes, Satyan, you have a question for me? Okay, there were two questions. Yeah, let me just get back to you. Let me first finish this part. Yeah, this is where we were. Okay, so you could go into, you could use HDFS FSCK command to find out about the file. Okay, okay, so it shows us. Okay, we are using this command called HDFS FSCK here. It says that connecting to the name node via this. Okay, and these are the commands that get executed. You can check this is basically h1. Okay, this is basically h1, and we are saying we are saying that you are connected to the host like this, and there is one block with a replication factor of 3. The length of the block is 46 bytes. Okay, and these three replicas are located on these IP addresses. These are the local IP addresses of H1, H2, H3, H4, and H5. Local IP address, so that these machines have two IP addresses. One local, so that they can talk to each other, and one public, so that people like us can talk to them. So they have two network interfaces, therefore two IP addresses. So you can see that, and then here it shows that the status of this file is healthy because the minimally replicated blocks are 100%. Okay, similarly here the average block replication is 3. All right, now we could do something crazy, as crazy as the setting the replication factor to say 6. While we have only 5 data nodes, we are setting the replication factor as 6. Okay, so the replication factor has been set to 6. Now let's check the HDFS block location again about this file. What happens now? Okay, it says that same thing here. Here it says under replicated. Okay, under replicated, it says that the target replicas is 6, but we have found only 5 replicas. Okay, the reason is that we are forcing it to create 6 replicas and we have only 5 machines. Okay, so right now it's trying to do as much as it can. There are 5, it has basically created 5 replication factor. It is not able to create, it has not able to go beyond replication factor as 5. Okay, so now you can see that the average block replication is 5. It's not going beyond that. Okay, we could take it back to say 2. We have set the replication factor as 2, and let's see what happens now. Okay, it says that replication factor is 2, but still it's having so many copies. After some time it will delete some of these. Okay, it has deleted some of the copies, and now you can see the total number of replicas is only 2. Okay, so Anand, you got your question answered, that in case you set replication factor as 3, it means you only will have 3 copies, not 4. Okay, It's total copies. Replication factor equals to 2 means only 2 copies in total, including the original. All right, let me answer some more questions. Okay, all right, here is a tough question. All right, let me try to answer everybody's question. Um, First, I need to answer Satyan's questions. There were a few questions from Satyan, which has been missed out. All right, let me try to answer that one. Okay, so Ashwini was saying that he's getting the permission denied. Okay, permission denied when name. The reason is that your present working directory, you can check the present working directory. Is it your home folder? If not, then you can just type cd and press enter. You will go to the home directory, and then you could do the nano. Okay, so that was Ashwini's question that I missed earlier. All right. Only data node since the file name is already known. Okay. Satyan's question is, I can see my file if I execute Hadoop ls, but not in Hue. Maybe the sorting issue. Okay. You go to the home directory. Okay. You go to the home directory and then check. Okay. You just try refreshing Hue. It should be there. All right. Here is a tough question that I need to answer. All right. So where is my data? Okay. Question is, where is my data? Do you know where the files are replicated? In this case, in case there is a 10 node cluster where we know, okay? So the blocks, in case there's a 10, where would you know each replication is stored? That you can see in this, that you can see here, while you say, while you execute this command, while you execute this command, okay, hdfs fsck blocks. Okay, when you execute this command, you will see the IP addresses. It shows that from here the IP address and the port number. All right. Okay. All right. In case you are wondering where are these blocks stored on data nodes, okay, you could go to slash slash what was that? What was that? Slash Hadoop and slash hdfs slash data. This is where data node process is storing its data. You can see this is okay. You can see that. All right. You can see this is the place. You can see blk. It means it's a directory. It's a block file. It's a block file which contains the data. For every file you can see something is happening. This is somebody's block I'm fiddling with. Okay, so basically you could check that every information is here. All right, so on every data node it stores data in this folder. You can see that inside Hadoop hdfs data, this is where the files are being cut into pieces and stored. All right. Okay, so I hope I've answered your question. I logged into Hue, but I can't see my file or directory created in Hue. Okay, so just check, did you do copy from local? Is Hadoop fs-ls showing the list of files? All right. Prabhu's question is, using command line, how can we find how many data nodes we have in cluster using HDFS command line? I think you have HDFS, and using HDFS, you could, okay, I had seen it multiple times. All right, you can see using getconf, okay, you can do that. It shows that there is only one name node, okay, and mm, actually, no, there is a way to actually list data nodes. I've recently used. All right, never mind. I'll share it with you later. Okay. In the meantime, you could or Hadoop fs minus ls, not ls. Let's just say. All right, never mind. I'll check it and let you know. I'm just sleeping it anyway. I'll just include it in our config. But in the you can simply use the you could go to hdfs.xml etc Hadoop and hdfs. Okay, inside conf you could see hdfs site. Okay, I hope it would have the data node. Okay, all right, so it shows that yes. All right, never mind. I'll just see what all. All right, so that goes into my to do. Parvez question is IPs are assigned dynamically? Please explain how 5 copies are created. Okay, so IPs are basically picked from the uh, data node, and it so in case of right now when we said we are trying to set replication factor as 6, but we had only 5 nodes in our cluster. So it maximized it. Okay, it maximized it. All right, good. You already got the question. So Dirpu's question is, what is the metadata files here? These are the small metadata over the blocks. Okay, so it's a slight small data that data node needs to store. Okay, all right. Now question from Prabhu is, when I do Hadoop fs minus ls, I'm only seeing minus my files. Can I be able to see other files? Yes, you can simply say Hadoop fs minus ls followed by your own folder, any folder. Let's say there is a folder called slash data. This is where I have stored all the data that is needed by this class as we go forward. Now you can go in there and check. All right. Now let's say I'm going into say pick. So under the pick folder, you see A here. You could say this and say cat. Okay. So I'm saying Hadoop fs minus cat data slash pig slash A. You see that? So all of you can read this data but cannot modify this data because this is common for all the students. And that's why I have not given you W permission even on HDFS in this slash data folder. All right. So Leela is saying that I've copied from local to Hadoop a file and also create directory in Hadoop. Okay. All right. Brilliant questions. So Leela, still you are not able to see the data. Okay. Um, uh, will that be okay with others if I give Leela, I make Leela presenter for 2 minutes? I think that will be better because probably some of others are also facing the similar problem and are confused with that. Is that a good idea? Okay, maybe you are in a wrong folder. Did you press home button here? Can you press home button? All right. Wait. I'm making Leela presenter for 2 minutes. Okay. All right, but you will be muted. All right. So, no. You go to file here, file browser on the top. Yes. It's not clickable. Ouch. Looks like it's not clickable. Okay, do one thing. Sometimes this gives a little bit problem. All right. So what you do is in here, I'll tell you what you need to do. Okay. So you go to this URL slash click on the menu here. Instead of home, type file browser at the URL. In the URL in here, instead of home, type file browser. FILEBROWSER. Enter. All right. Reason is that this browser is not clickable for you. Probably some browser issue. Okay. If that's the same case with you as well, okay, all of you can try this same thing. All right. Uh, thank you. Thank you, Leela. And okay, I think. All right. I'll just make you the. Okay. All right. All right. All right. So that solved Satyan's problem as well. Great. So, yes, so all of us are able to interact with HDFS. Okay? All right. So, the one part which we did earlier was this, where we said Hadoop FS minus copy from local, and we provided our local files, local folders name. Okay? Ouch, I am in the wrong directory. I need to go to my home directory. Okay, I'm saying Hadoop fs minus copy from local, and I could upload any file I want. All right, let's say I want to upload stocks.zip. This is how. All right, is that right, Anian? I'm saying Hadoop fs minus this. All right, now let's say there is some file on your desktop. Okay, there's some file on your desktop and you want to upload that into HDFS. There are two ways to do it. Either either you first copy that file from your desktop using SCP or WinSCP into H5, and then once that finishes, then you upload to using copy from local. Or you could simply upload it here, upload from here. Okay, you could simply upload here and say, actually, I do not have something uh, which I can just upload. All right. Also, everyone, do not upload things which are important to you or confidential in nature, because our sysadmins keep on reviewing the folders. Okay. And since it is supposed to be for educational, we do not expect that you will be storing your confidential data here. All right. All right. Great. So everybody is on the same page. All right. There was a question from, yeah. At the end of session, would be able to quickly highlight different HDFS and Hadoop command we covered in the class, or put it in a text file or share. Sure, sure, we'll do that. Okay, so we tried Hadoop FS, the following command: minus ls minus cat minus copy from local. Okay, now let's say we have just uploaded a file and we want to copy. You can upload really large files, yeah, up to 1 GB. Okay, Anand. Since we are running the whole cluster from SSD, therefore every data node has got around 200 GB. Okay, so we have a total of 1 TB space in the cluster, and out of that, 70% is dedicated to HDFS. That means 700 GB, and then out of 700 GB, if we assume that the replication factor is going to be 3, that means the total storage space available is 700 by 3. Okay, so be considerate on that terms. All right. Now coming back to it, good. All right, we will anyway share this. We can do. Let me just put it in my to do. Good. This session is going great. All right, and yes. All right. So we just now uploaded a file into Hue. From here, we can download to our local directory. Local directory, as in the H5. Let's say we want some file in the local directory. Okay. Let's say, which file do you want in the local directory? Let's say this file, say test.data. You want to copy this to my local folder, which is h5, h5.cloudxlab. Copy to local test.data. Okay, so we have got test.data. Okay, so we talked about minus copy to local. So you must try these commands for sure. Okay, good. All right. So this was our introduction to Web Console, Hue, and Ambari. There is nothing much to do because everything has been taken care. Also, the installation instructions you should go through in case you really want to install virtual machine, you can use it. Okay. All right. Did I miss anybody's question yet? Should we continue our discussion now from here onwards? Okay. So question from Anand is, do we have an example of files more than 128 MB so that it's stored in different blocks? Let me check. Actually, whenever I made somebody the co-instructor, what they did was they uploaded that file into the into their HDFS folder. So I'm not sure if there is a file which is bigger than 128 MB. We can upload it, that's not a problem. Sukhvinder's question is it possible to have videos offline? Honestly, I don't mind you having offline video, just that since we are using this account from YouTube, okay, uh, it doesn't provide you to download that video. You can basically use some YouTube downloader and download it. Okay. Okay. A question from Vivek Agarwal is that how to find out the actual raw blocks. Okay, is that the question? You want to see the raw blocks and see what's written in them? You could go to H5 after logging into the console here, and then you could say slash Hadoop. Okay, here you will see HDFS. So we are saying slash Hadoop slash HDFS and then slash data. Okay, this is where the data is stored on every data node. Prabhu's question is, can we also have access to the PPT you're using during the class instead of just the recording so that we can go through? Actually, it is available, isn't it? If you click on the presentation here, don't you see it here? Isn't it? So I thought it was already there. Oh, all right, you can see that it's there. Just that first and second session looks to be same. All right, yes. Okay, so go through this. That should be good. All right. So session number first and second, the video is the presentation is same. All right. All right. So yeah. So Parvez, I need to figure out how can I share with people. Maybe some torrent, some kind of BitTorrent kind of a model. Let me just figure out how I can share the videos. All right. For me, if I put it on Dropbox, it's going to be a little more challenging. All right. So that was pretty much about hands-on with respect to the HDFS. Okay. There are a few more questions to go, and then we can move on. Okay. When we interact using Hadoop command, that means it is always talking to name and data node. Yes. Yes. So name and or data nodes. Okay. Sukhvinder's question is, do we have any case where it just talks to data node? Not really. Not really. Okay. Asmit is saying you can download the videos using Video Manager. All right. You can try that. All right. Just that, yeah, we trust you that you are not going to distribute it publicly. but that's okay. If there is a needy person who really needs this and can't afford it, then you can share. It's up to your conscience. Okay. All right. Ashok is saying that copy to local, talk to data node or name node. It talks to both. Copy to local means we want to bring data from HDFS to local file system. Local as in local with respect to where you're standing. Now, where you're logged in. Okay. Copy to local, talk to data node or name node. First it talks to name node, finds the block, where are the blocks, and then starts talking to the data node having the corresponding block. Yes. All right. Yes, Satyan, that's good. Yes. So Sukhvinder, yes, it's good actually if you can commute because most of us travel, and that's the reason I'm allowing people to download these videos. And yes, that's the reason I actually downloaded other people's videos and watched it while traveling. Okay. Okay. Yes. Because that's the good use case. So let me figure out if I can make my videos available. Also, if you are traveling with a laptop, use it in a flashcards if your videos, because if you are watching a video from the hard disk during the movement, there will be a jerky experience. Okay. All right. So now should we start with the computer engine? A basic introduction so that you think about it, and then when we come tomorrow, you will have a basic understanding. All right. So what we discussed so far is that whatever file we upload in HDFS is distributed on many machines. Okay. So a single file is kept on many machines by slicing into blocks, and every block replicated on many machines. Okay, so effectively parts of the data is available in the network, right? That's what we discussed as part of our HDFS. Now let's talk about compute engine. A quick teaser to all of you. How fast can 1 gigahertz processor sort 1 terabyte data? Anybody? I'm asking how much approximately it will take to sort, how much time will it take to sort 1 terabyte data? And 1 terabyte data is how much? 10 billion names having 100 characters each. And the RAM you are having is 2 gigabyte. Okay. All right. All right. So I'm not looking for a way to calculate. I'm looking for a way I'm looking for your instinct. How much do you understand by the data? All right. The way I have done it in past, that I have broken the file into 2 gigabyte each, which means 1 terabyte data became 500 files. Okay, 1 terabyte data became 500 files. Then I individually loaded that 2 gigabyte file and then sorted 2 gigabyte file individually and then merged it. Merging sorted data is easier than merging unsorted data. Okay, so all right, so the way I did it was I broke the file into 500 parts and individually sorted 500 parts. Sorted means ordering the data. Okay, sorting means ordering the data. So I basically sliced these 10 billion names into into 500 different files, such that such that each file is having only 20 million names. Each file is having only 20 million names. Okay, and then I sorted those 20 million names individually and then merged them together. A question from everybody is that how does, if you are merging them again, isn't it the same effort? The answer is no. So, merging sorted data to produce sorted output is far more easier. Let's take let's take this simple case. Simple case is Simple case is that you have 10, 12, 13, 15. Okay, this is one set of data that need to be merged with 14, 14, 15, and 16. Okay, let's say you're trying to merge these two data sets which are individually sorted. We have sorted the first set and you have sorted the second one. You want to merge them together. All you need to do is stand in front of both the queues. Imagine that these are the two queues and you're standing here in front of them, both the queues. Pick up the heads of the queues. Whichever is smaller, you put them in the output. Okay, here these were both of the same value. Now it compared these two. Which one is smaller out of 12 and 14? So we are merging two lists which are already sorted. Okay, you just pick one of these, whichever is smaller. Now again, who is smaller out of this? This time, who is smaller? 14, 14 and this. Okay, so we get 14 out of it. And then out of these two, we again pick 15 and then 16. Alright, so what did I do just now? I quickly merged two lists so easily. Similarly, here also, what I did was I first broke the file into 2 gigabytes each and then read each one, sorted each one independently, and then merged these files such that the output is sorted. Okay? Oh, my voice is not audible at all. Hello? Okay, only for Vivek. Others can hear well. Vivek. All right. All right. So approximately for doing all of this magic, it'll take minimum of 10 hours. It might take 6 hours in case you have a really good processor, good hard disk, good RAM, but on an average, it would take around 10 hours. Or maybe more than 10 hours. All right. Good. So basically, what I wanted to do was, what I wanted to show you is that when we talk about 1 terabyte, it sounds like it's pretty small. And why do we think so? Because 1 terabyte hard disk is available in the market for 3 to 4,000 rupees. And probably everybody is holding a content, maybe movies, TV series, and songs, and everything combined together comes around to 1 terabyte already. So 1 terabyte sounds like small data. And our gut feelings so far have always said that when we sort data, when we do anything with the computer, it is actually fast. So we get a feeling that anything we do on the data is pretty fast. But in reality, it is not. Okay? You could imagine again that this same data was in your database, and there is only a single column in your table, and all of this 1 terabyte data is on that single column. The table has got 1 billion rows. If your table has got 1 billion rows and you are supposed to create an index, do you know about index? Index is something like, you create index means it will internally create sort of the way on the back side of the book you have the index of the words, right? That which words are sorted, words are ordered, and everywhere against each word it mentions that where did it find the word in the book. So it's exactly same way database also prepares an index so that when people come looking for a particular keyword, it can quickly jump to that location. All right, so indexing is nothing but ordering the data. So even if you have really brilliant database in which you have stored 1 terabyte data in a single table, it's going to take 10 hours time to create an index on it, while in your career at most the index creation might have taken at most 10 minutes. In my career, I have never seen the indexing process going beyond 10 minutes because I never indexed data so huge. So if if you try to even index 1 terabyte data, it is going to take maybe 10 hours. All right, because sorting process is is basically going to read and write a lot of data. And why is it so? Why is it so? It's not because our processor is the bottleneck. It's not because our computer is slower. Okay, the problem is that this 1 terabyte data has to be read from the disk, and while cutting it into 2 gigabytes, we have to write it back into the same disk. So this whole process of reading, writing the data from the disk is going to take humongous time. While sorting the individual piece is quite a standardized way. You can't go smaller on that. Okay? So basically, these are the reasons why sorting 1 terabyte data is a big deal. Now, what we need is sometimes we might need to solve this problem really fast. Let's say I want to sort 1 terabyte data every 2 hours. Second, I might have more than 1 terabyte data. Okay, also I might have to do it very often. So the current software is not solving our problem. The current mechanisms are not solving our problem of ordering 1 terabyte data. Therefore, therefore, we need a better system to do the sorting. And that's what is MapReduce about. Why? How can we do this? Algorithms are not the bottleneck. It is the read-write speed of the disk as well as CPU and RAM is the bottleneck, because algorithms theoretically cannot sort faster than the available algorithm. Available algorithms have been proven very well that they do a great job. You cannot have a newer algorithm of sorting which is considerably faster than the existing one. That's the theory as of now. Okay, so then how do you solve this thing? How can we make it faster? By using many computers. Google said, Google was a part of a challenge called sorting benchmarks. And sorting benchmarks is a very important challenge for all technology company. This is where everybody chest thump about their ability to do the sorting. And Google in 2011 won it by a very big margin. Okay, they were able to do sorting of 10 petabyte data, 10 petabyte data in 6.5 hours on 8,000 computers. Using 8,000 computers, they sorted 10,000 times the data I was trying to do, and they did it in 6.5 hours. And that was in 2011. And how did they do it? Using MapReduce. Okay, using MapReduce. All right. So this is where the core concept of MapReduce come in. So we'll take care of the MapReduce tomorrow. We'll discuss in depth how to do the MapReduce. We'll do hands-on, and we will try to go back and forth and try to find out what are the alternatives, what is the something wrong with the alternatives. And that exercise, trust me, that exercise of trying out other solutions instead of only Hadoop will give you a conceptual clarity, and you will understand the difference between how Spark does and how MapReduce does. And that exercise is something I want all of you to take through. All right. Okay, then we are running 3 minutes late. Okay, so see you tomorrow at the same time. All right. It is a great set of questions. I'm totally enjoying it. Please feel free to stop me and ask. And in case you are stuck with the hands-on exercises, feel free to schedule a one-on-one. Okay, for a half an hour. Just give me three different time slots. All right. Thank you, Anand. Thank you, Leela. Thank you, Satyan. Thank you, Ashmit. Thank you, Ashwini. Thank you, Prabhu. Thank you, Anyan. Thank you, Maimona. Thank you, Ashok. Thank you, Mohammed. Thank you, Vivek. Thank you, Sneha. Thank you, Parvez, Sudhakar, Suraj, Atrey. Thank you very much. Have a great day. That Vijay is saying that, and can we do middle of the week? That'll be very difficult, Vijay, because that's kind of going against the promise which I have made to people. All right. Have a good day. Bye bye. Stay connected.